Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about simplification of SOP type of Boolean function using CAMAP. Now let us take one example. We have function of ABC, that is f of ABC as it is indicated here. So we can see that the function has three variables ABC and summation m, that is 0, 3, 4, 7. So minterms are given and summation indicates that it is in SOP form. So minterms are given and we have three variables. So we know that we have to prepare a CAMAP with total 8 cells. So now let us prepare first our as usual CAMAP. We write variables AB and we give numbers to each cell, that is 0, 0, 0, 1, 1, 0 and 1, 1. 1, 0 and 1, 1. This you should notice and you should always remember how and why we are writing this. Then we have variable C. We write number for cell, that is 0 and 1. Now we write equivalent decimal number of each cell, that is 0, 1, 2, 3, 4, 5, 6 and 7. For here 5, 6 and 7. The pattern of writing a decimal number you should remember, and in previous lecture we have seen that why we are writing decimal numbers in such a way. Then we write 1 in the given minterms, that is 0, 3, 4 and 7. In all other cells, we write 0. Now we have to start preparing groups. The next step, that is to prepare a group. Now we have total 4 minterms, but code is not possible. We should try first to prepare the code if possible, but code is not possible. So we will have to go for pair. So this is first pair and apparently we can prepare this pair. Now we have 0 and 4. 2 ones are remain. So instead of going for individual or single group, we should prepare a group of pair with wrap around condition. We can wrap around the corners or left extreme column and right extreme column. So this can be a pair. Now, after making groups, we have to write the product terms. We have 2 pair, so we will prepare 2 product terms and we have to add both the product terms to make the final simplified output. We have 3 variables ABC, but we know that when we prepare a pair, we can eliminate 1 variable. When we write literals of the product terms, we should always remember that 0, variable 0, meaning is it is complemented, and if variable is 1, we know that it is uncomplemented. Now if we write a product term for the first pair, we can notice that for the AB, we have A is our most significant bit and C is the least significant bit. So we write in ABC form. So first we check for AB. So here we can see that it is 0, 1 for the cell number 3 and for the cell number 7 it is 1, 1. So A is converting from 0 to 1. So we have to eliminate 1. B, that is 1 and 1. So B is common for cell number 3 as well as for cell number 7. So we will have to keep B in the product term. Same way here on the C, it is a 1. So we will have to take a 1. Because B is 1, 1, it is B, and C, that is also 1. So we have to write a product term as BC. Same way for the another pair, we can again check for AB first. For the first number of 0 number of cell, we have 0, 0, and for the fourth number of cell, we have 1, 0. Again, we can see that A is converting from 0 to 1, so we will have to eliminate variable A because it is converting from 0 to 1. B remain common 0 0, but it is 0, so it is complemented, so B bar, we have to write B bar. And for C, it is 0 again, so we have to write the C bar. So when we write a product, we can write as a B bar, C bar. So we have written product terms for both the pair, both the group. We have two groups. So ultimately we can write our answer simplified, and that is f of ABC, that is equal to BC plus B bar C bar. Let us take another example, and that is f of ABC, and it is given summation m 2, 3, 4, 5, 7. We have given min terms, and summation indicates that it is in SOP form, and 3 variables. So we have to prepare a K-map as usual with 8 cells. We write variables A, B and C. We give number 0, 0, 0, 1, 1, 0 and 1, 1 for AB. We write variable C, and we give number 0 and 1 for the C. We write equivalent decimal number in each cell. So that is 0, 1, 2, 3, 4, 5, 6, 7. And we write 1 in each cell for which min terms are given. So we have been given, here we can see that 2, 3, 4, 5, 7. So we can write 1 in the given min terms. So 2, 3, 4, 5 and 7. We have written once for the given min terms, and in all other cells we write 0. So now next step is important, to make a group. Now again we can see that here we have total 5 min terms, but chord is again not possible. So we will have to go for making pairs. We can make one pair. We can make a second pair. Now in cell number 7, we have 1 is remain. So instead of going for a single group, we have to make a pair of this 7 either with cell number 3 or with cell number 5. With any cell we can make a pair. So we have make a pair like this. If pair is possible, we should not go for grouping a single one. Now we have to write product terms for each pair. Next step, that is to write product term for each cell. In case of pair, we know that one variable is eliminated. Suppose for this pair, see, vertically it covers both the cell. So C is eliminated. When it covers all the cell in the column or row wise, then that variable is eliminated. So here it covers entire column, so C is eliminated. So for AB we can write 0, 1, 0, that is complemented, so A bar B, A bar B. Same way here again C is eliminated, and we have AB, that is 1, 0, so we can write A B bar because B is complemented 0. And for the horizontal pair, we can see that it is for AB 0, 1 and 1, 1. So A is converting, shifting from 0 to 1, so we have to eliminate A. For B we can write 1 because it is 1, so B. And here for C it is also 1, so we can write B C. So we have 3 product terms ready, and we have to finally add all the product terms. So we have answer, that is f of ABC, that is equal to A bar B plus BC plus AB bar. Suppose we take another example, simplify Boolean function. Now function is given in this way in terms of literals. Then first we have to check that whether it is in standard SOP form or not. In this example we can see that it is in standard SOP form. In all the product terms we have literals of all the variables A, B, C, and that is why it is standard or canonical SOP form. If it is not in standard or canonical form, then first we have to prepare a standard SOP form and then we have to find the minterms. But in the given example, it is in standard SOP form, so we'll proceed further. Now we have to write a binary equivalent number. Suppose for A bar, B bar and C bar, if it is variable is in bar complemented, then we have to write 0. If it is uncomplemented, then we have to write 1. So for first, if we write, then we can write 0, 0, 0. A bar, B bar, C, 0, 0, 1. A bar, B, C, 0, 1, 1. A, B, C bar, 1, 1, 0. 1, 0, 1. And for A, B, C, we can write 1, 1, 1. Now for each binary number, we have to write minterm with equivalent decimal number. So M0, M1, M3, M6, M5, M7. For each binary number, we know the equivalent decimal number. For 1, 1, 1, we know that it is 7 and so on. So ultimately we can write summation of M 0, 1, 3, 6, 5, 7. These are the minterms given. And we can rearrange in this way. Summation M 0, 1, 3, 5, 6, 7. So once these minterms are ready, we can go for preparing the K-map. So now again for 3 variables we have to prepare our K-map with variables A, B and C, and we give equivalent decimal number to each group. We write 1 for the given minterms and we write 0 in all other cells. Now next step is to prepare groups. Here we can see that we can easily prepare one quad. If quad is possible, then we should not go for pair. And then again we have one pair and we have another pair. So 3 groups are prepared. We have to prepare minimum number of groups. Now next step is to write a product term for each given prepared groups. We have prepared 3 groups, so we will have 3 different product terms and then we have to add all the product terms. We have 2 pairs, so in each pair one variable will be eliminated and we have prepared one quad. In case of quad, we know that we can eliminate 2 variables. So if we write product term for the quad, we can see that it covers entire row. When it covers entire row, both the variables A as well as B is eliminated. And we can write for C, we have 1, so it is C. So we can write C. For another pair, we can write, because it covers entire column, so C is eliminated. And for AB, it is 0, 0, so we can write A bar, B bar. And same way in the third pair, again C is eliminated. And for AB, it is 1, 1, so we can write AB. And ultimately we have to add all the product terms. So f of ABC is equal to AB plus A bar B bar plus C. And this is our simplified Boolean function. Now let us take one more example with 4 variables. We have been given function f, that is ABCD, and we have been given the summation M and number of minterms have been given. So for 4 variables, we know that we have to prepare a K-map with 16 cells, 4 rows and 4 columns. We can write variable AB and numbers 0001, 1011. We can write variable cd and we can give equivalent numbers. We have to write decimal number in each cell. So we can write from 0 to 15. We have to notice the change 8, 9, 10, 11 like this. So this is important. Now the next step, that is to write ones in each cell for the given minterms. So we have been given 3, 5, 6, 7, 11, 13, 14 and 15. So we have written ones in all the cells for given minterms. In all other cells we have to write 0. Now next step, that is to prepare the groups. Here we can easily prepare one code. So one code we have prepared. Now you can observe that here for 5 and 13 number of cell we can prepare pair, and in similar way for 6 and 14 number of cell we can prepare a pair. But again, if we observe properly, then we can see that we can make a code for 5, 7, 13 and 15. So we can prepare one code. So when code is possible even with overlapping, then we have to go for preparing the code. And again we have another code is possible with overlapping. So we have prepared 3 codes. Here we can see that there is no redundant group, right? If there is a redundancy, then we have to eliminate that group. The next step, that is to write a product terms for the each group. So we write a product term for the code. In this we can see that it covers entire row, meaning is A and B both variables are eliminated. So we have to write for CD, and here we can see that it is 1, 1. So we can write directly as a CD. For next group, we have to check for AB, it is 0, 1 and 1, 1. So A is shifting from 0 to 1. So A is eliminated, and for B, it is 1, 1. So we can write B. Same way for CD, 0, 1 and 1, 1. So C is shifting from 0 to 1. So we have to eliminate C. And D is 1, 1 common. So we have to take D. So product term is BD. Same way for the third group. Similar way we can write B, and for CD it is 1, 1, 1, 0. So D is shifting from 1 to 0. So we have to eliminate D. For C it is 1, 1. So we have to write BC. So we can eliminate 2 variables at a time when we prepare a code. So if code is possible, we should always go for code instead of making pair with overlapping, but redundancy is not allowed. So final answer, that is f of ABC, that is CD plus BD plus BC. So this is our simplified Boolean function. Let us take one more example, f of ABCD, and it is given summation m and number of minterms are given. So for 4 variables we know that we have to prepare CAMF with 16 cell. We can write a variable AB. We can give number 0001, 1011. We can write a variable CD and we can give equally the number for cell. We can write decimal equivalent number for each cell, and we have to write ones in the given minterms. That is 2, 3, 8, 10, 11, 12, 14, 15. In all other cells we have to write zeros. Now next step is very important. We have to prepare groups. While preparing groups, first we have to see that if octet is possible or not. But in the given minterms, octet is not possible. So we have to go for code. So first code is very apparently available. So we have prepared one code. Now we can see that we can prepare two pairs for cell number 8 and 12 as well as for the cell number 2 and 3. But now with the wrap around condition, we can prepare a quad instead of making pair. We have to see whether with the overlapping if quad is possible, with the wrap around condition if the quad is possible or not. So here we can see that with the wrap around condition, it is sometimes known as a rolling condition. We can prepare a quad, and that is with the cell number 2, 3 and 10, 11. With the wrap around and with overlapping, we can prepare another quad. Same way for cell number 8 and 12, we can also prepare a quad. Here we can see that we have prepared 3 quads. All are overlapping to each other, but none of the quad is redundant. The quad with the red color encircled, we can see that cell number 15, one given in the cell number 15, that is not overlapped with any of the group. So this is not a redundant group. Now we have to write product terms for each group. We write product term, that is AC. For this quad, we can write B bar C, and for the next group, we can write A D bar. So we can write our final simplified answer f of ABC, that is AC plus B bar C plus A D bar. So this way we can solve very systematically any given Boolean function with the help of K-map. So thank you for watching my video. Keep watching. Thank you very much.